and welcome to the Firefighter Robot Project Update. I'm Chris.
I'm Carl.
I'm Sam. Together we are working on a robot for the Trinity College Firefighting Home Robot Competition. The purpose of the competition is to build an autonomous robot that will find a baby, rescue it, and extinguish any flames in the house. Of course, these are all representations using a baby doll, candles, etc., rather than the real things.
Here's the systems block diagram. In the middle we have the compute block, which is the main processor that connects to all of these other sub-blocks. There's the power supply chassis and PCB on the top left, and then these blocks are extinguish, cradle arm, sensors, and drivetrain. We'll go into detail of each of these blocks individually shortly. And here's Chris.
Alright, so starting with the extinguish block, this one is meant to put out any candles in the arena. It will use either air, water, or inert gas, and depending on which one of these, it needs to have enough material for all 3 candles. Moving on to the cradle arm, this will be modeled after a forklift, such as like this, using a pulley-style winch and these arms to pick up and grab the baby and hold it level so it doesn't fall off while we're moving it to the safe exit zone. The drivetrain. This will move the robot around the arena, utilizing 4 wheels to keep the robot nice and level, and also utilizing differential steering. This works by moving the motors relative to one another to create a difference in speeds to enable them to turn.
Alright, so the whole project will have a several printed circuit boards to contain the custom circuitry. They may be closer to each of their blocks, like the drivetrain may have a board and the sensors may have their own boards. And they'll be placed around the robot on the chassis. The power supply is important to the project. It provides power to all the systems blocks. We'll have a 12 volt and a 5 volt rail. The 12 volt rail will go out to each the compute and the drivetrain blocks, and then the 5 volt rail will go to the extinguish, cradle arm, and sensors blocks. The compute block is the main processor of the system, and it has interfaces to each of the sub-blocks because it controls all of the subsystems. It will be implemented either using a Raspberry Pi or a NVIDIA Jetson SoC, and so it will have general purpose I/O pins for connecting to the sensors and USB for connecting to the camera. We're also looking at implementing a network connection for external debugging over SSH. Included in the compute block is the navigation code block, which will input sensor data from the GPIO pins and then output motor control data to the drivetrain controller, and it will work closely with computer vision to determine its location and where it needs to go.
The next block is the computer vision block, which was mentioned in the past navigation block. The purpose of this block is to receive the sensor data for visual information from the cameras and process it. It will process that information in a way that extracts the pertinent information. Then that pertinent information, it can pass to the navigation code and the overall controls for the routine of the robot. The chassis is the static physical base of the robot that all the other physical components rest upon. Because this is a moving robot, these other components will need to be screwed in tightly and firmly to prevent anything from coming apart. The sensors block is the block which the robot will use to take in input from the outside environment. There are 3 main sensor types: odometers, cameras, and the microphone. These sensors will observe the outside environment and then deliver raw data about what they saw to the processor. Alright, up next we have a short little demo that shows what we've been working on with Robot Operating System and OpenCV. Thank you.
Alright, here we go. Now, as you see here, I wrote my launch file currently to open up the GUI and point to the targets for a competition, give the file path to that. I don't have those objects on hand though, so let's add an object just to see how this works a bit better. Just use one from the scene. Since I have my ID card on me, I can take a picture of that sucker. Okay, let's grab it. Alright, there we go. Now hopefully it'll be able to see it. There it is, lit up. Now let's just curious, let's see how this looks. Hey, there it is. It shows exactly where it finds it. So that is very good for our purposes, since that way we can find the target and locate it. While I'm doing this, let's take a look at the overall nodes and topics system that the ROS framework sets up. So let's say ROS 1. We can use our little nice little GUI to make a graph of that. Well, here's the publisher, which uses the drivers to get images from the camera, and it publishes them to the camera/image topic. Find object subscribes to that topic, and then it publishes to the object's topic, and then the object's detected node subscribes to that topic, and will print out any objects to screen. Hopefully this gives you a bit better idea of what Robot Operating System is, and we'll show you why we are all so excited to use it. Thank you.